Hi everybody, this is Tor Storley and I am back with another video. In this video, we're going to take a look at how we can generate the portfolio style data. Now, I'm only going to show you with individual stuff, but you can create portfolios with this package in Python. It's a package called Pyfolio, and there is an improved version of it because it's not maintained. The original pack is not maintained anymore. So we're going to look at something called Pyfolio-reloaded package, which is maintained by a different person, but it's still up to date. So we're going to use that, and we're going to run the output using that package. And then we're going to take the file, which is a Jupyter notebook, and we're going to analyze the results in Gemini Canvas. So that's the purpose of this video, to take a look at how that's going to work. And based on the Canvas output, we're going to create some slideshow and look at the results that way in a beautiful presentation format. So that's what we're going to do in this video. Okay, so I created a folder called Pyfolio Analysis, and you can see it here. It's just right in this folder structure. And I'm going to install my virtual environment and everything in this folder right here. Now I have Git Bash as a default set in my VS Code. I pip installed the UV package, and I have a reference to that. So make sure you do that first, get the UV package, unless you want to use pip to install your Python packages. The UV package, I did this because I wanted to kind of start using it because it's so much faster. It's written in Rust, and therefore it's super fast. So I want to give it a try, and that's what I did in this project. So install the UV package if you want to follow me. The first thing I want to do, I want to create some kind of project. And the way you can do that is simply use this command, UV init. And when I hit that, you're going to see that it's generating a structure under this Pyfolio_analysis folder. And it reads master here. So right now I initialized, and if you look at it, you have like a README file. You have a TOML file that basically give you the information about which kind of Python it requires, the version here, etc. You can add your own description, etc. And it has a main Py file, so you can see it just scaffold the basics. And you have the Python version shown, and you also initiate GitHub connection, so you can actually push this to GitHub. Okay, so I ran the UV init, and it created this folder structure. Now, however, I want to create a virtual environment under this. So I'm going to run this command and see what happens. And notice it created this venv under that folder. So now we're up to running the virtual environment actually. So the next thing then is to go and activate that. So I'm going to run another command here, source space .venv/scripts/activate. So let's run that. So now we're ready to start running some scripts to add the necessary Python packages we're going to need. So what I'm going to do then is I'm going to load Y-Finance so I can get some stock data. And I'm also going to load and install this Pyfolio-reloaded package. And in UV, you can use this command, UV space add space, and then the package names, Y-Finance space Pyfolio reloaded. So let's run that, and you can see it's run pretty quick, and it's done. Notice Rust ran all this stuff and installed all these packages. It's very, very fast. So that's what the UV installer did for us using Rust. Okay, so now we are pretty much ready to go. So now what I'm going to do is I'm going to add a new file that we're going to use for our analysis. Actually, I'm going to import a file so I don't have to retype everything. I'm going to import a Jupyter notebook file and put it into this folder right here. So let me do that. Okay, so here's my notebook. So as you can see, we're importing Pyfolio as PF. We're importing Y-Finance as YF. Here, I'm setting up a ticker for Palantir. And as you can see, I'm getting the history, max history from Palantir, which was from 2020, I believe. That's when they became public. And then I'm printing it out here. Then I'm creating some return using Python's percentage change function. And then I'm dropping anything with an NA because the first day of data will automatically have not a value because you're calculating returns. Therefore, you're taking the second day of data minus the first day of data divided on the first day of data. Therefore, there's nothing before the first day, so you can't really run anything. So it creates an NA. That's what we're getting rid of here. Then I want to look at the returns. Then I want to get some base reference, meaning a market benchmark. And in this case, we can simply refer to the SPY. By the way, a lot of this code automatically gets generated with CodePilot because it kind of spits it out and you can accept or reject it, whatever. So, it's like when you go something like this and you say history, and automatically it gives you some hints, and you can just tab through it. And that's what I did here. Because the stock prices comes in with open, high, low, etc., I'm choosing the close prices here in this case. Ideally, you should use the adjusted close because that will factor in any stock splits and any stock dividends, etc. But this Y Finance only returned the close. It didn't return the adjusted, although I'm pretty sure I can get a hold of it somehow. But I don't care. I'm just want to show you some data and then do some analysis on this. So here we are getting the Palantir returns and the benchmark S&P return. By the way, the SPY is an ETF that is based on the S&P 500 index. Here we're doing a join, an inner join. And the reason we do that is because we want to align the returns, meaning we want to start at the same date and we want to end on the same date. So that by using this inner join, you verify that one is not longer than the other. And then I simply want to print out the heads and the tails so I can actually see if that's the case. And then you can back test this by using inside this function, the Pyfolio create returns tier sheet, as you can see. And if you hover over it, you can see there's many parameters you can set here. And one of them is going to be that you can set the start date. If you're going to back test this, basically testing how good is this comparison, how good is this analysis, you can back test it in time, meaning you're using historical data to compare it with whatever the live data is. So you kind of split it, and therefore you can see how good it really is based on some of the models that it generates. So here I don't want to go too far back, so I'm going to 2022 in January of 2022. And then the benchmark, of course, is the S&P 500, in this case the ETF SPY. And then we're ending the script. So let's just run through this quick so you can see. I already import these two. Next thing is to actually get the data. So I'm running that, and it's done. You can open in Data Wrangler. We're interested in the close, and you can see there's nothing missing, and there's distinct 1,125 records here, 85%. So it doesn't go very far back. If you download the S&P 500, you will go back quite a bit. Okay, we can take a look at that, I think, if we run that as well. So let's create some returns. And when you do, we can look at it like this. And here you can see the first day has been dropped, and therefore the closing price rate of returns shows up like this. Now you can see there's 1,330 rows, and it only shows 10 per page in this case. Now let's get the stock data for the S&P 500. Now that's going to be a lot more because it goes back much further in time. So now let's take a look at that and see what it looks like. Notice this goes back to 1993, in February of 1993, and that's not comparable to what Palantir is because that went public in 2020, I believe it was. So we have to take both of them and align them using this inner join. So let's do that. And now let's print that to see if it matches. So we print it out. Notice it starts on 10/1/2020. That was the first public date it was trading, I guess. And here you can see this one is also aligned to the same date. And the tail end you can see is the last date, which is this one, 1/16. And here you can see 1/16. So we're aligned the two data sets, so now we can actually run a analysis over it. And what's beautiful about this package is it does all the heavy lifting for you. Now, I've done it in R before, very similar stuff, but it takes a lot of work. You got to refer to all these functions, all these charts, etc. Here, you simply have this one-liner, and you give it like a back-testing date, and then you list whatever it is, and you create what is called a create return tier sheet. Now, this one has a lot of function, and I'm not going to go into it here, But if you want to start analyzing this, you can see there's all kinds of stuff you can do here. It's like portfolio analysis. So let's run that and see at the output what it looks like. Notice it gives you a lot of warnings, etc. here. And again, you can see it gives you a summary of the start date and end dates. It also gives you the in-sample month, 15 months, and out-of-sample months of 48. So it's going to compare historical data with what it used to create these models. So here it gives you the in-sample result, out-of-sample result, and the all. So you can see annual return, cumulative returns, annual volatility, Sharpe ratio, karma ratio, stability, max drawdown, etc., etc. Now, the thing about it is you get this stuff, and then you got to figure out, okay, what does it all mean? And you can also see it has a drawdown table, meaning, how quickly did it recover after dramatic downturns and how many days did it take? What was the peak dates? What was the valley dates? And what was the recovery date? And then how many days did it take, etc. But you're also getting this stuff, which is some warnings. This package will give you some charts. And again, the purpose of this particular video is not to go through the results here like this, but to show you how you can analyze it and using one of the AI tools to do it for you. So I'm going to leave that up to you to study it because there's a lot of stuff to dissect in this Pyfolio package. But you can see there's cumulative returns on a log scale. You have the actual daily returns, as you can see here. You can basically get an idea of how volatile it is. And you have the green area, and then you have the red area, the out of sample area. And then you have rolling portfolio beta, meaning how risky is this asset compared to the market. So it's being calculated over these ranges. And then you have rolling volatility, and then you have rolling Sharpe ratio. When you compare the Sharpe ratios, you can actually compare other companies with yours because it creates a ratio of risk to return. Because one company can have a lot of risks, but it also may be a lot of return. But when you compare it to a low-risk company with maybe lower returns, it's really hard to compare it because one has more risk, so you expect more return. But by putting the Sharpe ratio in place, you can actually compare them because it's a ratio over how much return over the risk. So here you can see the drawdown periods, how it went up and down. And there's all kinds of plots here. So as you can see, you get bar charts. You have the distributions of the monthly returns. And then you have quantiles based on daily data, weekly data, and monthly data. And then it's the end of the script. So right now we created this workbook, and I'm going to save that. And what I'm going to do is I'm going to see if I can analyze this. So that's the next step. So what you want to do is you want to go to this Google Gemini. The first thing you need to do is go into this tools and choose Canvas setting. Okay. So you get tools and you go and choose Canvas like this. Okay. So what I want to do is I want to use a prompt that I created to actually get the result. So let me pick that up and start from there. All right, so here is my prompt in Gemini Canvas. Create an analysis presentation and explain the output and the meaning of the different financial metrics in the, I said Pandas data frame output for this IronPython notebook, meaning the Jupyter notebook. Include visuals as needed. And the other thing I want to do is I want to grab that Jupyter notebook I just created and let it read that. So now I included that. So let's run that, and I'm just going to still the video till it finishes so you don't have to watch it work. Okay, so it finished, and it produced this slideshow, 1 out of 8 it says. Now, this might change every time you run this, so some of the slides might be better than others. I don't know. Also, you can export to slides, and I'll show you an example of that. Now, notice you can step through it here. And it can tell you what it did. So here is the main findings. You can see your slide deck on Palantir's financial performance is ready. I've included the HTML code above, which visualizes the high returns and high risks associated with the stock based on this data provided. So you can see here they explain the metrics. Tells you the annual return, cumulative return, volatility, Sharpe ratio, max drawdown, alpha, beta, Sortino ratio, etc. So what you can also do is you can show the thinking. So here you can see as you step through it, it tells you about how it approached this to produce the output. So extracting the metrics, detailing the insights, constructing the slides, clarifying the periods, And it says, I encountered a minor setback with the Google search tool, but it's not a showstopper. So it kind of gives you what exactly it went through to produce this. And what you can do, you can download this. So you can create a PDF for download, but you can also create a slideshow out of it. So let's see what happens once it's finishing here. So here it's downloaded, and up here you can see when I double click, this is what it looks like. So let's just step through this quick. You can see here is massive accumulation, and it gives you some ideas. Now, obviously, this has to be verified. You have to double check these numbers and see if the way it explains it makes sense, but that means you have to understand the topic too. So here you can see, wow, it comes up with some images of, the growth and up and down, the volatility, the very high beta. You can see there's almost 2 times as much as the S&P 500, the movement in the stock. It has been a roller coaster, in other words. Here you can see max drawdown, so it's very volatile. And you can see the Sharpe ratio, the alpha, the tail ratio, the Sortino ratio. You have strategies like this, and it also tells you where it's getting the images from. Now, I created this before, and let me see if I can bring that up so you can kind of compare it what this stuff looks like with the one I created before. So here you can see the previous one I created, and you can see there's a little different slides, different imagery. I created a slideshow out of this one. So I clicked on that Generate Slides button, and you can run the slideshow. So here we are. You can see here's the landing page. So when you click, it goes through it. You can see here's a summary, and it has some images that it produces. It tells you the benchmark it used, the time period they used, and you can see it gives you some indicators. But these slides are different from the previous one, so you might have to run this a couple of times to get some decent looking slides, or you have to mix and match. And here you can see the returns, the kurtosis, the skew. You can see large positive outliers. You can see in-sample returns, out-of-sample returns, the cost of growth, the drawdown, some nice imagery, alpha, beta. And here it gives you some pie chart for the risks, and the cumulative growth path. It's slightly different looking chart here. So personally, I like this slideshow better than the previous one. Depending on the prompt you're using, it can produce probably more similar to what you want to see. And also it tells you where it gets these thumbnails and all the imagery from. That's a little bit about how you can use Pyfolio and Gemini Canvas to generate slideshow based on a Jupyter notebook. I hope you like this video, and if you do, please give me a like and consider subscribing to my channel. Thank you so much for watching.